Right, in part 2, we concluded with the volume expressed in terms of A, B, and Y. Now we also determined connections of dy dt in our previous videos, and dv dt, and other quantities. Now, if we differentiate this volume, we can find the rate at which this volume is changing. V is this pi a squared y cubed over 3b squared. If we differentiate this, then we can have that dv dt is now equal to pi a squared y cubed over b squared. And remember, as the volume changes, then the rate of change of y will change. This height y is changing as the volume in the container changes. So we're also multiplying this by dy dt. So now we've expressed the relationship between the rate of change of volume of water in this container with respect to all the other variables, a, b, y, and we're multiplying here by the rate of change of y with respect to t. And lastly, we need to calculate the value of the unknown. The unknown which is the depth of water, y. So we have that 2, which is r, the rate of change of water per minute, is equal to pi a squared, which is 4 squared, which is times 16, times y cube, which is 1 cube, which is 1, and it's over b squared, which is 9, and we're multiplying by dy dt. Let me just rewrite that so it can be all on the screen. Now this is equal to pi times 16 times 1 over 9 dy dt. Remember r, so this is our formula, so I should have written this here instead. This is what we find as the rate at which the surface is rising when the depth of the water is y. So here we have r in the numerical values. Provided we know what dy dt is, it's multiplied by pi times 16 times 1 over 9. And that solves it. So this is a problem based on the rate of change, which is the derivative of a function. Thanks for watching. I'm Alistair.